Hello and welcome to Unit 11. We're going to start a new unit on areas and volumes. And I will let you know that there's quite a bit of this on the ACT. There's also quite a bit of this on when we do our study of calculus. So I would say pay attention. Some of this is going to be review. However, I am putting both lesson 1 and lesson 2 together, and lesson 2 is definitely new material. So here we go. When we want to look at what are the formulas for the areas of the figures below, I would say that these are basic area formulas. And if you are a student that is going to be headed to Algebra 2 Trig next year, you're a student that is eventually going to take pre-calc, and you're a student that is eventually going to take calc, you need to know these basic area formulas. We're in e-learning, so right now there isn't this you have to memorize, but if we were in traditional schooling, I would require that the following were memorized. When you are asked for the area of a circle, we're asking for how many square units would fit inside the circle. And we covered this in the circles unit. The area formula is pi r squared in a circle. When we discuss a triangle, in a triangle, again, something you should have learned in middle school, the area formula is 1/2 base times height. Some students write it as base times height divided by 2. They both work, and this is the formula for the area of a triangle. When we want to look at a rectangle, the area is just base times height. Some students prefer length times width. Either works, and these are what you use for a rectangle. And last but not least, you can still use in a square. You're welcome to still use base times height or length times width. It works. But what is special in a square is that S for side is the same on both sides. So if I take base times height, that's S times S. And so another popular way of talking about it is the side squared. So you need to make sure that you know those specifics. Now, we talked a lot about four-sided figures in a previous unit, and here's what's nice. Everything in the parallelogram family, that's all base times height. So if it's a general quadrilateral, base times height doesn't work, or for a trapezoid, or for a kite, but for the parallelogram family, it works. I do want to make a special note that the rhombus will have an additional specific area formula to it. All right, so let's get started. Again, these are considered right here, these are considered review topics. We won't explicitly do those examples. We're going to move on in this lesson to parallelogram, to rhombus, to trapezoid, and a kite. All right. Core concept, the area of the parallelogram is base times height. Please note that whenever we refer to a height, you are always referring to a perpendicular height. So to be clear, this slant, that slant is not a height. Why? Because that slant does not make a 90-degree angle with the base. The height makes a 90-degree angle with the base. In a rectangle, it's pretty self-explanatory because you have 90-degree angles. And then here are two additional pictures. They're all considered parallelograms. That's specifically a rhombus and a square, but they all work. All right, so find the area of the parallelograms. Whenever I teach area, I'm going to teach it in a very the same way all the time. We have area is equal to base times height. In this formula, or in this picture, excuse me, the base is 15 and the height is 5. 7 is extraneous information. I don't need it. And let me pull up a calculator. So if we want to determine what the area is of that parallelogram, we're going to take 15 times 5. And this gives us 75. And because we're in centimeters, we would say that the area is 75 square centimeters. So if I wanted to know how many squares that are 1 centimeter by 1 centimeter fill that up, it would be 75 of them. Okay, example 2, and this is why if you looked at the filled in notes that sometimes these aren't as easy as it seems. Again, I would identify that this is a parallelogram. Then I would say that the formula associated with the parallelogram is base times height. In this problem, the base is 10. What I don't have is the height. So in order to find the height, I'm going to look at this triangle. I'm trying to find the height. This is a 60-degree angle and the hypotenuse is 6. I'm going to use one strategy, which is to use a 30, 60, 90 triangle. If I do a 30, 60, 90 triangle, 6 is the hypotenuse. That means this is the short side, which would be half of that. And that means the height would be 3 root 3 if I wanted to use a 30, 60, 90 triangle. Another option is you can use SOHCAHTOA. So if you wanted to use SOHCAHTOA, this is still 60, this is H, this is 6. H is opposite the 60. 6 is the hypotenuse. O and H means we'll use the sine. So the sine of 60 is equal to H over 6. So that means H is 6 sine 60. And if I do 6 sine 60, that gives me approximately 5.2. And if you're wondering, okay, Nat, what if I decide, however, to use special right triangles? Well, let's notice that 3 root 3 is also the same value. So we had to do all of that work to find H. So now I can go back to my original formula and type in 10 times 5.2, just move the decimal over, so we get 52 square centimeters. Now let's go to talk about the area of a trapezoid. The area of a trapezoid, in a trapezoid, you end up with two bases. So you add those together, you multiply by the height, and you take it divided by 2. So some students will look at it as 1/2 height times base 1 plus base 2, or you can look at base 1 plus base 2 times the height and divide it by 2. That's the same thing, and some kids like to work with that better. So in problem 3, I identify that it's a trapezoid, and area is equal to the height times base 1 plus base 2 over 2. So the height in this problem is 12. Base 1 and base 2 are 14 and 27. It doesn't make a difference which ones you want to use. And then I divide by 2. So in this case, the 5 is extraneous information and it does not need to be used. So in order to find my answer, I'm going to take 12 times 14 plus 27 and divide that all by 2, and I get 246. Now this problem did not have any units in it, so this would just be units squared. All right, number 4, this is why this one is a little bit of a doozy. Again, we always start out by asking ourselves, what is the object? The object is a trapezoid. Then I write down the formula, and the formula for a trapezoid to find its area is the height times base 1, base 2 divided by 2. And in this problem, we have bases 1 and bases 2, but what I don't have is the height. So, again, I don't have the height. Base 1 is 16, base 2 is 26, all over 2. But the key to this problem is noticing that it is isosceles. So if it's isosceles, it makes a nice rectangle in the middle where this space right here, this length, has to be the same as this length because it's symmetric. Well, if this is 16, that makes this 16. Well, 26 minus 16 is 10, and you have to divvy that up evenly, so that means each of these are 5. So in this case, to find H, we have a triangle where this is 13, this is 5, and I want to do H. So I'm going to use Pythagorean theorem. So 5 squared plus h squared is equal to 13 squared. So 25 plus h squared is equal to 169. If you subtract 25 from both sides, you get 144. And so my height is 12. So now I'm going to replace the h with a 12. All right, and let's figure out that value. So I'm going to have 12 times 16 plus 26 all over 2, and that gives me 252. And in this case, they gave it to me in meters squared. All right. Our next grouping is area of a kite, and this is where I had told you earlier that while a rhombus, you can still use base times height because it's in the parallelogram family, you can also use the area of a kite where it's 1/2 the product of the diagonals. So again, there's no adding like there was in a trapezoid. You are multiplying all those numbers. Again, some students like to write this as area is equal to the diagonal 1 times the diagonal 2 divided by 2. All right, here we go. So the first thing I do is I identify that this is a kite. The area formula for the kite is diagonal 1, diagonal 2 over 2. Now, they didn't give me what the full diagonal lengths were. You have to add them together. So it doesn't make a difference which one is diagonal 1 and which one is diagonal 2, but this diagonal right here is 9.2 times, or excuse me, plus 9.2, so that's going to give me 18.4. Diagonal 2, I have to add 6.9 plus 13.8, and this is going to give me 20.7. And I multiply those together and divide by 2. And this gives me 190.4. This would be meters squared based on the units that they gave me in the problem. Okay, in problem 6, I would notice that this is a 4-sided figure, and they have given me that all 4 sides are congruent, and that makes this a rhombus. And while I can use base times height, they didn't give me what those values were. So I can also use diagonal 1, diagonal 2 divided by 2. Because this is a rhombus, then the diagonals, they bisect each other. So that means this is 12, giving me a total of 24, and this is 8, giving me a total of 16. So I can take 24 times 16 and divide that by 2. And so I get 192 units squared. All right, before we move on, I want to be crystal clear about what work needs to be shown for full credit. If you want full credit, I need to see not necessarily the area formula written out, but I need to see the numbers in the formula. So what I'm doing right now is highlighting what I will need to see in your work for full credit this week. So again, I need to see how you are arriving at values if they're not explicitly in the problem. All right, so hopefully this gives you an idea. And if you had to find H here, I don't need both. I either need to see 30, 60, 90 work, or I need to see SOHCAHTOA work. So to be clear so far, this is what you need in order to receive full credits for your homework. All right, so in the next examples, these are examples where you have to put together several area and add them together. What do I mean by that? Well, first we're going to look at this triangle. When I think about the area of a triangle, the formula is 1/2 base times height. Well, you have to look at this triangle where this is the base and this is the height. And since this is 9 and this is a parallelogram, this is 9. And then the middle piece is a rectangle, so opposite sides are congruent, that would make the base 9 in this triangle, the height 7, and we divide by 2. So that's going to be 63 divided by 2, and that gives us 31.5 for the area of the triangle. Now when I want to do the area of the rectangle, we're going to add that, and the base is 3. Oh, let me back up. Hold on. The formula is base times height, where the base is 3, the height is 9, and so that gives us an area of 27 that we're going to add to the 31.5. And then last but not least, we have this parallelogram. All right, and when we look at, sorry, I don't know why I put a 9 there. That was incorrect. We don't know that it's a rhombus, it's just a parallelogram. So when I look at the parallelogram, it's base times height, and we know that the height is 9. But we need to figure out what the length with the base is. Well, if I know I'm 16, this part is 7, this part is 3, that's 10, so that would make the remaining piece 6. 6 times 9 gives me 54. And when you add all of those together, we get a total that the area of this figure is 112.5 units squared. And last but not least, problem 8. On problem 8, we're going to separate this into the area of the rectangle, and we're going to add to it the area of the trapezoid. So when we look at the area of the rectangle formula is base times height, and that's 8 times 4, which gives me 32. Then we're going to look at the area of the trapezoid. The trapezoid is height, base 1 plus base 2 divided by 2. So the height is 4, base 1 is 14, base 2 is 8 divided by 2. So it's not isosceles, but remember those slant heights really, they don't affect the area. And in the interest of time, I'm letting you know that that gives you a total of 44. If you want to do it by hand, this is going to be 2 times 22. That gives me 44. And this gives me a final answer of 76 feet squared. All right, if it were me, this is my personal opinion, I would stop the video at this point because what I'm about to teach you is significantly different. And I would work on the practice packet or the assignment I gave you, and you are prepared to do problem or pages 1 and 2. To be clear, no work, no credits. And if you're wondering what is the minimum amount of work you need to show me, I need to see not necessarily the formulas. If you want to write that work, that's okay. But what I really need to see is formulas where the numbers are filled in. Now let's welcome to the last half of this formula in this, or last half of this lesson, and we're going to talk about areas of regular polygons. As a reminder, what does it mean to be a regular polygon? It means that I am a closed figure where all the angles and all the sides are congruent. So in the first half of this lesson, we dealt with finding the area of circles. We dealt of triangles, rectangles, squares. And then we extended that to parallelograms, trapezoids, kites, rhombus. Well, what happens if I want you to find the area of this pentagon? None of those area formulas that we've done up to now apply. That's what today's lesson is about. So in order to do some prep work to figure that out, we have to talk about what happens when we take a polygon and we are going to put it inside of a circle. What happens is the center of the circle becomes the center of the polygon. The radius of the circle becomes the radius of the polygon. And then what we need to talk about is the apothem. The apothem is when we take, we make a triangle, and the apothem would be the height or the altitude of that triangle. So what is the work you're going to have to do? Let's take the example of a five-sided figure. This would be the center of that five-sided figure. If I draw from the center to the vertices, these are the radii or the radius. Then if I drop from the center, if I drop an altitude, that's the apothem. So I'm going to redraw this triangle over here to the right, and this is the relationship that you have to understand. This is a radius of the polygon, just because it would be the radius if we would circumscribe it inside of a circle. This distance that is up and down, this right here is my apothem. And then this distance would be half the side of my polygon. So again, what I did is I just redrew this triangle over here to the right. So this is my apothem, this is my radius, and this is your half of your side. That is ultimately what is really going to save you today. All right, here we go. In the diagram, WXYZ is a square inscribed in circle P. Identify the center. Well, the center of the circle is P, so the center of my square would also be P. The radius of the circle is going to be P to Y or P to X, and so either of those segments would be the radius of my square. The apothem is the height to the side that's in between them. So this PQ would be my apothem. And the central angle, remember from the last unit that a central angle is an angle where the center is the vertex of the angle. And we would be looking at YPX, angle YPX, or you could write it as XPY. In the next problem, they want us to find some angle measurements. In the diagram, ABCD is a regular pentagon inscribed in circle F. Find each angle measure. All right, here's what's going on. Okay, remember how we had this pentagon. F is the center. If I draw a radii from F to B like we did in the picture and F to A, I have to find this angle first. Well, think about this. I could draw radii to all of the vertices, and that would give me a total of 5 angles. Those 5 angles have to equal a total of 360, but I just want one angle. So in order to find this angle, angle BFA, I just need to take 360 divided by 5, and when I do that, I get 72 degrees. So angle AFB is 72 degrees. That was kind of sloppy. All right, next. Next, they want me to find AFG. Again, let me redraw it. So I have A to F to B. We just determined that this was 72 degrees. So what they're asking for is they drop down an apothem, and the question is asking for AFG. Well, that's going to be half of the central angle. And since the central angle was 72, we take half of 72, and that gives us 36 degrees. Lastly, they want to know what angle GAF is, so they want to know this angle that I just highlighted in purple. Well, if I redraw this triangle where this is F and this is G and this is A, this is a 90-degree angle. We determined this was 36, so this angle right here, if I take 90 plus 36, I get 126 degrees. I'm going to subtract from 180. So 180 minus 126 gives me, 180 minus 126 gives me that it is 54 degrees. Now let's talk about how we find the area. All right, it's not a terrible formula. What's terrible is when you don't know one of these values. So the area of a regular polygon is you take the apothem times the side length times the number of sides divided by 2. So if we had to find the area of this regular polygon, my area formula is the apothem times the side length times the number of sides divided by 2. In this problem, they were nice. 6.5 is the apothem. What they did not give you was a side length. They do give you the number of sides because you can count. I have 1, 2, 3, 4, 5 sides, and we divide by 2. So in this problem, what do we have to do? We have to find a side length. What am I going to use to do that? Well, if I know that this is a right triangle with a hypotenuse of 8 and a 6.5 side, I can use Pythagorean theorem. So I have 6.5 squared plus x squared equals 8 squared. So that means x squared is going to equal 8 squared minus 6.5 squared. So I'm going to take the square root of that. So that's going to be the square root of 64 minus 6.5 squared. And we get that it's 4.6. We'll round it to 4.7. However, what you found was not the entire side length. What you found is that this piece right here was 4.7. This side is also 4.7. And if I take 4.7 and 4.7 and add it together, I get 9.4. So the entire side length is 9.4. So the area of this figure, 6.5 times 9.4 times 5 divided by 2, and that didn't, 6.5 times 9.4 times 5 divided by 2. So when I take 6.5 times 9.4 times 5 divided by 2, we get 152.75. If the directions would ask us to round to the nearest tenth, I'm cool with that. We would get 152.8 square units as my final answer. Again, if you want full credit on a quiz, or excuse me, on your assignment, you would need to show me the work on how you derived your answer. All right. Find the area of the regular polygon. So I can't use base times height. I can't use 1/2 base times height. This is not anything in the parallelogram family. This is not a kite. This is not a rhombus. This is not a trapezoid. It's none of those. So I have to resort to the area of a polygon. So I'm going to start with my area formula. Area is equal to had a brain fart. Hello, good morning. All right. And it's not. It's like 1:55 in the afternoon. All right. It's apothem times the side length times the number of sides divided by 2. And in this problem, the only thing they gave me was the side length and the number of sides. So I'm going to have to find the apothem. So let's fill in what we know. We have to find the apothem. We know that a side length is 7. And if I count the number of sides, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 sides. And so our goal, our quest, is that we have to find the apothem. All right, so what am I going to do? Here's the center of my polygon, and I am going to draw a triangle. Well, the first thing I need to do is I need to figure out that angle measurement. And as a reminder, I could keep drawing those radii out, and you would have a total of 10 angles. And if you would add up all of those angles, it makes a full circle, and that's 360 degrees. So to find the angle, I'm going to take 360 divided by 10, and so this is a 36-degree angle. But that's not the apothem. In order to get the apothem, I have to draw an altitude. So now let me retrace just this half of the triangle. In doing so, remember this whole side was 7. So if I cut it in half, this is 3.5. This is your apothem. And this has been cut in half to be 18. So to find the apothem, we're going to use SOHCAHTOA. 3.5 is opposite 18, A is adjacent, and so if I use SOHCAHTOA, this is going to be tangent. So the tangent of 18 is 3.5 all over A. So I get A tan 18 is equal to 3.5. Divide by the tangent of 18. So my apothem is going to be 3.5 over the tangent of 18, and I get 10.8. So now I put 10.8 back into my formula. And if I take 10.8 times 7 times 10 divided by 2, we get that the area is 378. And because they did not give me any units, it would just be 378 square units. All right, let's do another one. Find the area of a regular pentagon with an apothem of 7 centimeters. So if you would like a picture, we have a pentagon that's 5 sides, and we are given that the apothem is 7. So again, I'm going to start out with my formula. The area is equal to the apothem times the side length times the number of sides all over 2. In this problem, they gave me the area and they gave me the number of sides. I have to fight for the side length. So let's fill in what we know. We know that the apothem is 7. We don't know the side length, and we know, and this is an S, all right, and we know that the number of sides is 5 because they told us it was a pentagon. So we have to find, we have to find the side length. All right, so again, if I draw from the center to each of the vertices, all 5 angles would have to equal 360. So I have to figure out this angle first. So 360 divided by 5 gives me a 72-degree angle. Then I need to cut it in half, and let me just redraw that triangle. Well, that would make this a 36-degree angle. The problem gave us that the apothem was 7, and my goal is I have to find this length and then double it to find the whole side length. All right, so how I'm going to do that? I'm going to use SOHCAHTOA. All right, this is opposite, this is adjacent, so that means we're going to use tangent. So the tangent of 36 is equal to x over 7, so that means 7 tan 36 is going to give me half of the side length. So if I do 7 times the tangent of 36, I get that it is 5.1. But remember, we just found that this is 5.1. This side is also 5.1, so when you double it, the total side length is going to be 10.2. So to find the total area, I'm going to take 7 times 10.2 times 5, divide that all by 2, and we get 178.5 square units. And for our last example, find the area of a regular decagon with a radius of 20 meters. You have to recognize that a decagon means that it is a 10-sided figure. And I don't know that I would draw that real well, but I don't know that I need a drawing. What I know is that I've got some type of really large 10-sided figure. I'm going to draw its center. I'm going to draw its triangle where each of the radii are 20. And I am going to have to fight for two things in this problem. If our formula is the area times the side length times the number of sides over 2, the only thing the problem gave me was the number of sides, which is 10. So we have to fight for the apothem and the side length. So again, if each of the radii is 20, all right, the first thing I have to do is to find that angle. Well, there's 10 sides. So I would take 360 divided by 10. So that means this is a 36-degree angle. But then I have to cut it in half. And when I do that, the radius remains 20, and this becomes an 18-degree angle. So it doesn't make a difference which one you want to find first, but let's say we want to find the apothem first. All right, so to find A, I'm going to use SOHCAHTOA. Well, 20 is the hypotenuse, A is the adjacent, so that would be cosine. So the cosine of 18 is equal to A over 20. So your apothem is 20 cosine 18. That gives me 19. Okay, so my apothem is approximately 19. So what I have so far is 19 times the side length that I don't know times 10 over 2. Well, we have found side lengths before. All right. Next, in order to find this value, I'll just call that x. I am also going to use SOHCAHTOA. This time the hypotenuse is still 20, but my x is now the opposite. So I'm going to do the sine of 18 is equal to x over 20. So that means 20 sine 18 is x. So I get 6.2. But remember, 6.2 is just half of the side. You have to double it to get the whole side. So that means the whole side would be 12.4. All right, so I'm going to put that in. So in order to get the area, I'm going to take 19 times 12.4 times a 10-sided figure divided by 2, and we get 1,178. And that would be square, oh, excuse me, we have meters. That would be meters squared. You are now ready to tackle Unit 11, Lesson 2, the assignment on page 3. As a reminder, if you want full credit, I need to see work that shows me how you're getting your values. Reminder, you can meet at 11 a.m. on Zoom on Tuesdays and Thursdays for help. Enjoy!